are probably thinking, Mrs. Ford, I have no idea how to do this. But I bet if you got past that for a second and thought about it, I bet you could figure this out. In how many ways can you arrange 5 books on a shelf? Now, here's how I want you to think about this. Okay, this is brand new for most of you. I really don't want the chit-chat. I want everybody focusing so we get off to a good start. This unit is sometimes considered difficult. So we need to really be on top of it from the beginning and we'll be fine. So I have 5 books that I'm going to arrange on a shelf. All right, so I'm going to draw a picture of my shelf. Here's my shelf. And there are 5 slots on my shelf because I have 5 books. So here's my pile of books, okay? I'm going to grab a book out of the pile and I'm going to put it right here on the shelf, right? How many choices of books do I have? I'm going to pick one, but how many do I have to pick from? 5. So there are 5 options for this first slot. Now that 5 does not mean I'm putting 5 books there. It means I have 5 choices. Got it? So I grabbed a book and I put it in that spot. Okay. Now I'm going to grab another book and put it in this slot. But remember, I already put a book on the shelf. So how many are in my pile now?
4.
There's only 4 to choose from now. So this blank has 4 choices. Okay, any ideas how many choices? And then, and by the time I get here, I only that's it, right? Because there's only 1 book left that goes here. These get multiplied together. You have 5 choices, and 4 choices, and 3 choices, and 2 choices, and 1 choice. So there are 120 ways that you could arrange those 5 books on a shelf. Now, if you have your graphing calculator with you, I need you to get it out. This kind of situation where we take 5, 4, 3, 2, 1 and times them all together is called 5 factorial. This is called factorial. It looks like an exclamation point, but we don't say 5. We say 5 factorial. Oh, where's my chimney?
Is that on camera?
Yeah, that's on video. Just another embarrassing moment. Okay.
That's on video?
Now, clearly, you could type into your calculator 5 times 4 times 3 times 2 times 1, or you could even do that one in your head. But what if we had a bigger number? I really don't want to waste all the time doing, 16 times 15 times 14 times 13, because what factorial means is whatever number you're starting with, you go down by 1 all the way and times them all together. So here's what I'd like you to do on your calculator, and try to remember this. So if you don't have a calculator today, you might want to write this down so that when you are responsible and bring a calculator to class, you will know what buttons to press. If you press your math button, and your math button is in the very first column, right? For me, it's underneath my green button. You will notice across the top of the screen you have options. The first option is math, and then it says NUM, and then it says CPX, and then it says PRB. PRB stands for probability. So we're going to click over to the probability menu because probability is part of this. We use factorials in probability. If you look now, you clicked across to probability, right? Do you see the factorial symbol in your list now?
Yes.
Okay, so if we want to type in 5 factorial, we go back to the home screen. Okay, so press clear, go back to the home screen, press 5. Now, math, over to probability, down to factorial, press enter, and then enter, and does it say 120?
Which one's factorial?
Exclamation
That's
point.
magic.
So one more time, let's do a different number. Let's do 7 factorial, all right? So in my home screen, regular screen, I just press 7. I'm going to do 7 factorial. So I press 7.
Wow.
Now what do I press? Math. And then I click over to probability, click down to factorial, and press enter. And what did you get for 7 factorial? 5,040? Okay? All right, so the setup for the problem will be 5 factorial. The answer to the problem is 120 ways. Now let's look at the next question. Keep your calculators out because we're going to need them. In how many ways can 9 people stand in a line? What'd you say? 9 factorial. Ethan?
362,000.
You've already figured it out?
Are you serious?
9 people in a line is
362,880.
880?
Yeah.
There are 362,880 ways for 9 people to stand in a line. Now, how many of you made the transfer from the book problem? 5 books in a line was 5 factorial. 9 people in a line is 9 factorial. In general, n things in a line will be n factorial. So if I said to you, how many ways can I arrange 18 pictures on a shelf? You would say 18 factorial. If I said how many ways could I arrange 10 seniors in a row, you would say 10 factorial.
Can we just say factorial for the answer?
You have to write the actual number, but the setup would be 10 factorial. Okay. Let's look at number 3. Because number 3 is about the same, but a little bit different. Bryce, we're doing problem 3 now.
Yeah.
Okay. You wanna, there we go, thank you. In how many ways can prizes be awarded for 1st, 2nd, and 3rd place in a race with 10 contestants? And now think about this for a second. Do they all 10 get a prize? No. You're only giving 3 prizes. So here's 1st place, here's 2nd place, here's 3rd place. All right? So you got 10 runners. Okay? How many choices do you have, or how many possibilities are there for a 1st place winner?
10.
10. Right? Anybody can win. So you have 10 choices. And again, the 10 in that blank means 10 choices.
Quick question. When they do like gambling bets, like probability, they do that?
And we're gonna do some card problems. By the time we're done, you are gonna know how to find the probability of being dealt 5 cards and exactly 2 of them are queens. You're gonna get that figured. We're gonna know how to do that.
Could I rig the NCAA tournament?
But we have to start at the beginning.
Can we go to Las Vegas after that?
So there are 10 choices for 1st place. How many choices are there for 2nd place? 9. How many choices are there for third place?
8.
8. Multiply those together, and that's the answer to the question. 720. 720. Mrs. Ford has 8 jumpers and 10 shirts. How many different outfits are possible? Because you know I don't worry about things matching, so we just pick a shirt, pick a jumper, here we go.
Time to start the day.
So when I get ready to start the day, and I go into the closet, I have to make a choice. I have to choose a jumper, and I have to choose a shirt. How many choices do I have for jumpers? 8. I'm going to pick one. I have 8 choices. How many choices do I have for a shirt?
10.
So how many outfits are possible?
80.
80. Very good. Perfect. You're getting the hang of it. Mr. Ford has 5 sport coats, 12 shirts, and 10 pairs of pants. How many outfits does he have?
600.
Now, he needs to make 3 choices, right? So he's going to pick a sport coat. Katie Bumgardner, how many choices does Mr. Ford have for a sport coat?
5.
Yep. Now he's going to pick a shirt, Katie. And now he's got to pick a pair of pants. So how many outfits altogether does Mr. Ford have?
600.
600. In how many ways can the home row, I should say of the keyboard, I left the word out there, in how many ways can the home row of the keyboard be arranged? Okay, that's like when you sit down at the keyboard, that's where your fingers start, okay, that home row. And these are the letters that are in the home row. Suppose you wanted to pull a practical joke on somebody and you rearrange their home row. How many ways could you do that? Well, how many letters are there in the home row?
9.
9. So there are like 9 blanks. You're going to somehow pop those letters off, and you're going to put them back down in a different order. So you've popped off these 9 letters. Here they are in your hand. How many choices do you have to put here?
9.
9. And then
8.
what's this answer going to end up being? 9 factorial. This is going to be 9 factorial, so the answer is right here. This time, gang, we're arranging 9 letters in a row. Right? How many ways can we arrange 9 letters in a row? 9 factorial. Which is that big number right there. In how many ways can you answer 10 true-false questions?
20 times. 20.
No, way more than that.
900.
Let's think about this for a second. We have 10 questions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 questions. Megan, you all right?
Wait, what did you do? So
We have 10 questions.
10 hours.
I didn't study, so I'm going to have to guess on this test. How many choices do I have for first question? 2.
Is it 2?
How many choices for the second question? 2. In fact, won't all of these have 2s?
Yeah.
So it's 2 to the
So the answer is 2 to the 10th. We are multiplying 2 times 2 times 2 times 2 times 2 10 times.
1024.
1,000.
So 1,024 different ways you could answer this test.
It's kind of crazy. I've had like quiz like that.
In how many ways can 4 different prizes be given out if there are 10 people in the contest? All right, now stop and think a minute. How many prizes are you giving away?
Wow.
4. So you have to make 4 choices, kids. Okay, here are my 10 people right here. I'm gonna give 4 prizes away. So how many choices do I have to get my first prize? 10. How many choices do I have for my second prize? And what do I do with all these numbers? Multiply them, always multiply them. So I don't know what that is. 5,040. So there are 5,040 different ways I could do that. All right, let's take a look at number 9. How many license plates are possible if they must consist of 2 letters followed by 3 non-zero digits? Okay, now wait a second. We're going to make a license plate. And we're going to have 2 letters followed by 3 non-zero digits. That means 3 numbers that aren't 0. All right, now I want you to really think about this for a second. I'm going to pick a letter to put here. Joelle?
Blank be 26, next one 25.
The first blank is 26.
What if the second one?
Because how many letters are there to choose from?
No,
26.
2 the same letters.
Now, here's where you got to be careful.
Oh, isn't it 26 again?
I have to decide if this could be 26 again, or if it has to be 25. Now, wait a minute. Have you ever seen a license plate that had 2 letters that were the same?
Yeah.
Yeah. So, let's say I picked an M for this first spot. Could I pick M again for this second spot? Yes. So it's 26 times 26. Noelle, you got it?
Yeah, and so the next.
And wouldn't it be 9, 9?
Now, it's non-zero, so it can't be 10, it would have to be 9. There is the answer to the question. Question number 9. 2 letters followed by 3 non-zero digits would be 26, 26, 999. Because you can repeat letters in a license plate. Tim?
All that is
Now, number 10. Uh-oh, now Noelle, read number 10. See what it says? We're going to build the same license plates, but this time nothing can repeat. So somebody's made the rule, nothing can repeat. So what did you say, Noelle?
26, 25, 98.
Exactly. Now, does that make sense to you? Number 11. How many 4-letter call signs are possible if every letter is allowed? A call sign is something like
SOS.
WIBC radio or WENS TV.
WTHR.
WTHR, there you go. So if we're allowing every letter, and we're going to build 4-letter call signs, how many choices? 26, 26, 26, 26. So when you grow up and you create your own TV station, it could be WWWW. How about number 12? Exactly. In number 12, they're saying you can't repeat. You can still use all the letters. So we got 26 options, but you can't repeat them. So that would be back. Oh no. Look at number 13. It says how many are possible if no vowels are allowed. There's 5 vowels. We're going to just say A, E, I, O, and U are going to be our vowels, okay? So that would be, now I'm doing problem number 13. All it says, it goes back to question number 11 and says except you can't use vowels. So does it say anything about repeats?
No.
No. So the answer would be 21, 21, 21, 21.
21.
Now look at number 14. No vowels, no repetition.
Maybe it's slower if we just write it like that.
No, you're supposed to be working them out, but we're just not taking class time to do that. I'm assuming you can type that in on your calculator.
Yeah, I see that one.
All right, so now this is going to be problem number 14. How many are possible if no vowels, no repetition? 21, 20, 19, 18. All of these problems are word problems. You have to read them carefully. All right, you ready for number 15? Here we go. A baseball team has 9 starters. How many different batting orders are possible?
9 factorial.
9 factorial. It's 9, 8, 7, 6, 5, 4, 3, 2, 1. Does that make sense to you? Katie Baumgartner, that could be a softball question. Does that make sense to you?
That's kind of crazy.
I'm the coach. Are you a softball player? She's our manager?
She's the manager.
Okay.
She's their hidden talent.
I'm the coach.
What did you say?
She's their hidden talent.
I delegate the batting order responsibility to my manager. So now Maya is going to determine the batting order. How many does she have to choose from to go first? 9. Somebody goes first, then she only has 8, and then 7, 6, 5, 4, 3, 2, 1. So 9 factorial is the answer. Uh-oh. Number 16. How many are possible if the pitcher bats last? Now, wait a second. Here is my batting order. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my batting order. The only rule is the pitcher has to go last. So how many choices are there for this blank right here? 1. That's the pitcher. So how many players do I have left?
8.
8. So I have 8 choices, and then 7, 6, 5, 4, 3, 2, 1. So that will be 8 factorial. Maya?
Is taking a number to have is taking a number to the power of it's the same number as the base, the same as factorial. So it's like doing 9 factorial the same as 9 to the power. No, because 9 factorial, let me use a smaller number. 5 factorial is 5 times 4 times 3 times 2 times 1. That's 5 factorial. 5 to the 5th would be 5 times 5 times 5 times 5 times 5. See the difference? Yeah. Number 17. Now the pitcher bats last and the best hitter bats third. That's going to be 7 factorial. Because if you look at your 9 blanks, the best pitcher or the best batter has to be here, and the pitcher has to be here. You don't get choices. That has to be those people. So how many people are left? 7. So now you've got 7, 6, 5, 4, 3, 2, 1. That is 7 factorial. Uh-oh, now number 18, we got a new concept here. You ready? I
promise I won't go too much longer, but I'd like to get through a few more of these basic concepts. How many 1-digit, 2-digit, or 3-digit numbers can be formed using these digits? Now, here is the tricky part. This is really 3 different questions, because we could do 1-digit numbers, how many choices do I have? I pretend that you took these 6 numbers and you cut them up, and you put them on pieces of paper, and they're right here in the bowl. You need to make a 1-digit number. You're going to reach in the bowl and pick one out, right? How many choices are there? 6. So there are 6 different 1-digit numbers that you could make. Now what about 2-digit numbers? This is a separate problem now. Now I'm going to pick 2 digits. So here are the digits, right here. Here's my bowl with 6 numbers in it.
6.
So I have 6 for the first digit
5.
and 5 for the second digit. So there are 30 of those. Well, what about 3-digit numbers? Now this is a whole different problem now. They're starting over. We're making 3-digit numbers now. So that would be 6 times 5 times 4. Does that make sense to everybody?
Those are 6 factorial.
So that's not 6 factorial. 6 times 5 times 4, I don't have the 3, 2, 1 on the end. I only have this much, so that's 120.
Well, the same as those going to become 6 factorial.
Okay, so stop a minute and think. All right, think a minute. The question was, how many would I have all together? So if I have 6 of these, and I have 30 of these, and I have 120 of these, how many do I have all together? 156. What does all together mean? Add them up. It's different. Within each problem, we multiply, don't we? But when you have different problems and it says, okay, it could be 1-digit or 2-digit or 3-digit, we add them up. We total them up. We do each problem individually and then we total them. Okay, we're going to do 3 more problems. Number 19, how many 5-letter words can be formed from the letters of the word Chevy? What do you think? Don't give me that. You should have a thought.
Oh, we got it.
It's just like the one we just did, only now I'm using letters. How many letters do I have here in my bowl? 5. I want to form 5-letter words. So how many choices do I have? 5? 4? So what's the answer? 5 factorial, 120. That's exactly right. How about Precal? 6 factorial. Precal, 6 factorial. How come it's 6 factorial this time? 6 letters.
666.
No, it's not 666. It's 6 factorial. Now we're going to skip down to number 23. Look at number 23. That's a big word, isn't it? How many letters are there? 11. So did you say 11 factorial? Hey, you're right, but there's something else going on. Can you see what it is? I didn't have to worry about it with the word Chevy, and I didn't have to worry about it with the word Precal. But I do have to worry about pre-calculus because in that word there are repeated letters. How do we handle what we call repetition? Repeated things. It's not a subtraction, it's a division. So I'm going to take my 11 factorial, and we use 11 factorial because there are 11 letters, period. However many letters there are, that's what you start with. So we start with 11 factorial. Now, I'm going to divide that by 2 factorial because there are 2 C's. But wait a minute. I have to divide by another 2 factorial because there are 2 U's. And another one because there are 2 L's. If we had 3, we'll do one in a minute. If we had 3 of the same letter, then we would divide by 3 factorial. Okay? Now, we need to type this into our calculator. No. Now, when you type this in, please remember that if you have more than one thing in the denominator, you have to put it in parentheses. So we're going to have 11 factorial. Everybody remember how to get factorial? Divided by parentheses. Now, what's 2 factorial? What does it mean to be factorial? 5 factorial means you start with 5, right? What would 2 factorial mean? 2 times 1, isn't it just 2? So we're really just dividing by 2 times 2 times 2. See if you get 4,989,600. 600. That's the number you should get. That's the answer.
Yep.
If you calculate what's in the circle, this should be the answer.
So, the 11 stands for the 11
Because there are 11 letters in the word.
So you do 11, 10, blah, 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 and then multiply 11 together and divide.
Yep. All right, I want to do one more of those repeat words. Everybody's favorite is Mississippi.
Favorite?
Well, because it has a lot of repetition. So how many ways could we arrange the letters of the word Mississippi? How many letters are there? Start with that. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 11. So we start again with 11 factorial. Now what are we going to divide by? We always divide if things are repeated. So we have 4 factorial for the I's, 4 factorial for the S's, and 2 factorial for the P's. Let's type this in, and then we'll be done for the day. Please do not lose this sheet. We still have a couple problems to do on it. So 11 factorial divided by, please put this in parentheses, 4 factorial, 4 factorial, and 2 factorial. You should get 34,650.
Yep.
On Wednesday, we are going to have a quiz over this. So we're going to finish this, these practice problems. I'll give you last year's quiz on Tuesday. We'll look at that, we'll do that, and then Wednesday we'll have a real quiz. You cannot get the answers, boys and girls, if you don't have a calculator. So make sure you have your calculator, Thomas.
Yeah.